We discussed about the four main chemical compounds in cement and their functions, how they contribute to heat generation and strength gain. Also, we discussed about the fineness of cement, how it contributes to strength gain and heat development. We can control the percentages of the four compounds and get the required properties. However, sometimes we need to add admixtures to control properties, and we are going to discuss that in this topic. Admixtures we can divide into two groups, mineral admixtures and the chemical admixtures. Under the mineral admixtures, we are going to discuss about the cementanious materials, pozzolanic materials and non-reactive materials. Under the chemical admixtures, we will discuss air and train agents, self-controlling admixtures and plasticizing admixtures. Admixtures are the materials other than cement, aggregate and water that may be added to impart a specific quality to fresh concrete or to hardened concrete. Admixtures are added at the time of mixing of fresh concrete, usually less than 5% of cement, to achieve desired properties. Now let's see the properties that we can get from adding admixtures. We can increase the workability of fresh concrete. We can accelerate or retard the setting. We can reduce bleeding. We can increase the strength of hardened concrete. We can obtain concrete with less permeability to increase durability of concrete, and also we can save money by adding admixtures. As discussed earlier, mineral admixtures can be supplementary cementanious material, pozzolanic material or non-reactive materials. Examples for supplementary cementanious materials are fly ash, ground granulated iron blast furnace slag and amorphous silica. We mainly add supplementary cementanious materials to reduce the cost by replace a portion of the cement. However, we can improve some properties in cement as well, like sulfate resistance and cement alkali reaction by adding supplementary cementanious materials. Here you can see some pictures of supplementary cementanious materials. As we discussed before, mainly we add supplementary cementanious materials to reduce cost. And also we can improve some properties as discussed. We can improve the consistency and the workability of fresh concrete due to the high cohesiveness. Also, some materials delay concrete hardening and act as a retardant. We can use them to control bleeding and control heat generation and cracking. Pozzolanic materials also comes under the mineral admixtures. Pozzolanic materials are materials with little or no cementanious properties but react chemically with calcium hydroxide at ordinary temperature to form compounds possessing cementanious properties. Non-reactive materials also comes under mineral admixtures. Examples are ground limestone, silica flour and hydrated lime. Physical and chemical properties of mineral admixtures are important. Here we are looking at physical properties of some mineral admixtures: shape, specific gravity, average particle size, bulk density and the surface area. When you look at the shape, most of these admixtures has spherical shape. The specific gravity is around 2. Average particle size is different to different admixture. Bulk density is different. Surface area is different. Depending on these properties, the properties that we get in the concrete mix also will be different. Here you can see the chemical properties of some mineral admixtures. You can see the percentages of different oxides in different admixture. Depending on the percentage of these oxides, the properties in the concrete also will be different. Different admixture contributing different properties in fresh and hardened concrete. In this slide, you can see different admixtures and how they contribute in fresh concrete properties. When you look at fly ash class F, it reduces the water demand, it increases the workability, it reduces the bleeding and segregation, increases the setting time, decreases the air content, and decreases the heat of hydration. When you look at class C fly ash, it reduces the water demand, it increases the workability, it reduces the bleeding and segregation, it can lower or higher the setting time, it reduces the air content, and it can lower or higher the heat of hydration. When you look at the slag cement, it reduces the water demand, it increases the workability, it increase or lower the bleeding and segregation, it increases the setting time, it has no effect on air content, it decreases the heat of hydration. Silica fume increases the water demand, decreases the workability, decreases the bleeding and segregation and no effect on setting time, decreases the air content and no effect on heat of hydration. Now let's look at some natural pozzolans. Slate has no effect on water demand, increases the workability, no effect on bleeding or segregation, no effect on setting time, no effect on air content, and reduces the heat of hydration. Clay has no effect on water demand, increases the workability, no effect on bleeding or segregation, no effect on setting time, no effect on air content, but reduces the heat of hydration. And this one increases the water demand, decreases the workability, decreases the bleeding and segregation, no effect on setting time, and reduces the air content, and no effect on heat of hydration. Now let's look at effect of different admixture on properties of hardened concrete. Here we are going to look at early age strength gain, long-term strength gain, abrasion resistance, drying, shrinkage and creep, permeability and absorption, corrosion resistance, alkali-silica reactivity, sulfate resistance, freezing and thawing, de-ice scaling resistance. When you look at the early age strength gain, different admixtures has different effects. So if you look at these ones, fly ash class F, shale and clay, they decreases the early age strength gain. But when you look at silica fume and this one, it increases the early stage strength gain. However, class C of fly ash doesn't have any effect on early age strength gain, and slag cement can increase or decrease the early age strength gain. When you look at the long-term strength gain, all of these admixtures increasing the early age strength gain. And when you look at the abrasion resistance, none of them have any effect. And also the drying, shrinkage and creep, none of them have any effect. When you look at the permeability and absorption, all these admixtures reduces the permeability and absorption. When you look at the corrosion resistance, all of these admixtures increases the corrosion resistance. Alkali-silica reactivity is a lowering by all of these admixtures, and most of these admixtures increase the sulfate resistance apart from the fly ash class C. When you look at the freezing and thorough, none of them has any effect. And when you look at the de-ice scaling resistance, it may lower or have no impact when you consider all the admixtures.